Okay, in this video, we're going to take a look at the Unit 2 review for Math 1111 College Algebra. And I am omitting some of the questions on the review because I know that I'm not going to ask you those on the test inside D2L. As I mentioned today in class, I think you'll find that the online exam will actually be easier than the in-class exam would have been, because there's some questions just the way that you have to write the answers and things, or the graphing and stuff that I would normally ask you to do, I'm not able to do inside D2L. So I think you'll find that some of those it's going to actually be a little bit easier than anticipated. So I've actually omitted question 1 and 2 because I'm not going to be asking you to state the domain of the various functions. So we're really going to begin with question number 3. And it says to find f plus g at x. So to think about what that means I'm going to substitute x into function f. I'm going to substitute x into function g. And then I'm going to add the two results. Okay, and I'm going to try to color code these for you, try to help you see what's going on. So we're going to use kind of this magenta color for function f, and I'm going to use green for function g. So initially, to find function f of x, we substitute x into function f, and it's going to give us a value of x squared minus 1. And then I'm going to substitute x into function g, and that gives me 2x plus 3. And then I need to add those two results together. To add those two results together, we're going to combine like terms. So looking at that problem, there's nothing to combine with x squared. So I have x squared plus 2x, nothing to combine with that. Then I have minus 1 plus 3. Minus 1 plus 3 is positive 2. So f plus g at x is x squared plus 2x plus 2. Guys, please be super, super careful with your adding, subtracting, multiplying, and dividing. If you have trouble with positive or negative numbers, please take the time to pull out your calculator and do the calculations there. Okay, so you're not asked to state the domain, so I omitted part B. So the next question is really question 4A. And it is f minus g at x. So with this one, we're asked to substitute x into f, get the answer, x into g, get the answer, and then to subtract the two results. So again, using the same f and the same g that we were originally given, when I plug x into f, I get x squared minus 1. When I plug x into g, I get 2x plus 3. And then I want to subtract those two expressions. And again, to subtract, we combine like terms, but it is really important that you pay attention to the signs. Okay, so you want to watch your signs. When I look at this, I remind myself there's an understood one here. And I like to go ahead and distribute it through so I don't make an error in my calculations. So I would have x squared minus 1. I just brought down the first piece. Then I'm going to distribute. Negative 1 times 2x is negative 2x. Negative 1 times positive 3 is negative 3. And then I can combine like terms and hopefully not make a sign error. There's nothing to combine with x squared. There's nothing to combine with minus 2x. I have minus 1, minus 3. That's going to give me minus 4. So ultimately, f minus g at x is x squared minus 2x minus 4. Please, 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 please be careful and watch your signs. Okay? Again, you're not going to be asked to state the domain. So we're actually moving on then to question number 5. Okay, which is, it looks like f g of x. Okay, mathematically, this is the notation for multiplication. So we're going to plug x into f, get the answer. Plug x into g, get the answer. And then we're going to multiply. Okay, so when I substitute x into function f, I get x squared minus 1. When I substitute x into g, I get 2x plus 3. To multiply those two things together, we use full. First, outside, inside, last. So I would have x squared times 2x, which gives me 2x to the third. X squared times positive 3 gives me positive 3x squared. Minus 1 times 2x is minus 2x, and minus 1 times positive 3 is minus 3. And if possible, at that point, I would combine like terms. However, I don't have any like terms, so my answer for f times g at x is ultimately 2x cubed plus 3x squared minus 2x minus 3. Guys, it's really straight, flat out substitution. Okay, so don't overthink it. Don't get tripped up. The biggest thing is paying attention to the signs. Then we move on to question 6. It's division. Looks like a fraction, but it's really division. So we find the value of f of x. We plug x into f, get the answer. We plug x into g, get the answer, and then we divide. So if I substitute x into function f, I have x squared minus 1. If I go back and I substitute x into function g, I get 2x plus 3. And that being a fraction, if it were possible, I would simplify it. This one doesn't simplify, so your answer for f divided by g would be the quantity x squared minus 1 divided by the quantity 2x plus 3. And again, you're not asked to state the domain. And then we move on to question 7. Question 7 is the composition of two functions. And remember, a composition involves a sequence, so you have to perform the operations separately in a specific order. And we basically work our way backwards. We take x and plug it into f. When I plug x into f, I get x squared minus 1. I then have to take that answer and substitute it into function g wherever there is an x. So my g is really 2x plus 3, but I'm going to remove the x, and in its place, I'm going to put x squared minus 1. And then I want to go through the process of simplifying that equation or that expression. So 2 times x squared is 2x squared. 2 times minus 1 is minus 2 plus 3. And finally, I'm going to combine like terms. So I have minus 2 plus 3. So that gives me 2x squared plus 1. And that is G composed with F at X. Okay, so those first 7 problems, the first 6 were operations on functions. Number 7 is a composition of functions. The second set of questions, questions 8 through 19, deal with the topic of inverse functions. Okay, so for questions 8 through 19, we're going to be dealing with inverse functions. And there's a little bit of a review built in here, because the first question I ask you, given you this table, is to say, does the given table or given relation represent a function? And that was something we talked about on the first test. And so if you'll remember to make that decision to decide whether or not a table represents a function, you want to ensure that there's no repeat in the x values. And so if I come up here and look at my x values, which is the year, okay, I have 1994, 95, 96, 97, 98, 99, 2000, 2001, 2002. Okay, there's no repeat there. And so since there's no repeat in the x values, I can say, yes, this is a function. Then I have to ask myself, does the given function have an inverse? Well, to decide whether or not you have an inverse, you want to look to see that there's no repeat in the y values. So if I go back up here and look at my table, I notice that there were 7 storms 2 times, so it repeats. There were also 12 storms 2 times and 15 storms 2 times. So there is a repeat in the y values, which means that this particular table does not have an inverse. It is not 1-to-1. And so then question 10 asks you to actually find that inverse. But we just said the inverse doesn't exist. So how can we find it? We can't. So we simply say it does not exist. The abbreviation for that is DNE in the world of mathematics. The next set of questions has to do with this particular graph, and it does give you the equation of that graph. It's y equals 2x minus 4, and there are 2 points labeled on the graph. You have the y-intercept, which is at 0, -4, and you have the x-intercept at 2, 0. And again, it goes through and asks you a series of questions about, does the relation represent a function, and how do you know? Does it have an inverse, and how do you know? So if you'll recall, to decide whether a graph of anything is a function, we use the vertical line test. And I can visualize vertical lines on this graph, and it's only going to cross 1 time, which is acceptable. So that lets me know that yes, this particular equation does represent a function. Okay, so I would say yes, it does represent a function because it passes the vertical line test. Then they ask me, does this equation or does this function have an inverse? In order for the graph to have an inverse, it has to be 1-to-1, and we determine whether it is 1-to-1 by using the horizontal line test. So again, if I visualize horizontal lines, the horizontal line only intersects my graph one time at any given point. So I can say here again, yes, it does have an inverse because it passes the horizontal line test and is 1-to-1. Then it wants me to create the graph of the inverse. And the way that we do that is we use these points that are already labeled for me on the graph. When you're thinking about creating the graph, if you think about the original graph, you have the ordered pair x, comma, y. On the inverse graph, you're going to have the ordered pair y, comma, x. So I initially have the ordered pair 0, -4, which is my y-intercept. Well, when I invert that, it's going to be -4, 0. My y-intercept, my 0 or x-intercept is 2, 0 on the original. When I invert it, it's going to be 0, 2. And so I can plot those 2 points, -4, 0, 0, 2, and I get 2 points which define a line. And so I know that I'm going to have some equation that looks something like that. Again, it doesn't have to be perfect, but that's how you do it. But again, you're really not going to be asked any kind of graphing on the test. So the main thing is to know how to make a decision if an inverse even exists. All right. Then we have this last set, and you're given the equation y equals x cubed plus 1, and it goes through and it asks you, is it a function? Does it have an inverse? And so what I want to do there is I want to look at the graph. So I'm going out to my graphing calculator. I'm going to put it into the graphing calculator. So I'll press y equals underneath the calculator screen, and I'm going to enter x raised to the third power, arrow out of the exponent, add 1, and graph. And I get this blue curve. I noticed that vertically, I could draw a vertical line and it would only cross it one time. It is also true that it would only cross the horizontal line. It does not truly flatten out here kind of in this center. Okay, it's a curve, so it's always going up or always going down just slightly. You can't really see it on the graph that we have created here. So I can say here, based on my calculator graph, that yes, it is a function because it passes the vertical line test. And yes, it has an inverse because it passes the horizontal line test. And so then it asked me to find that inverse. So I have to think about the original equation, and it's a 2-step process. Step 1 is to interchange x and y. So I would rewrite my equation as x equals y cubed plus 1. And then the second step in the process is to solve for y. That means ultimately to get the y by itself. So I would subtract 1 from either side so that I have x minus 1 equals y cubed. Then I need to undo the cube. The inverse or the opposite of a cube is the cube root. So I'm going to take the cube root of both sides. So I have the cube root of x minus 1 equals y. Once you have it solved for y, that particular expression represents f inverse. Question 19 actually asks you to verify that, but that's not something I can ask you inside D2L, so you won't be asked that on the test. Okay, so that covers 2 of the topics on the test. It covers operation and composition of functions and inverse functions. So I'm going to pause here and then go to a second video to finish out the review sheet so that it won't be so long for you guys.